Basic statistics are a fundamental aspect of data analysis as they provide the tools and methods for understanding and interpreting data. Some of the most common statistical concepts used in data analysis include mean, median, and mode. These are measures of central tendency that indicate where the center of the data lies. The mean is the average of the data, the median is the middle value when the data is sorted, and the mode is the most frequently occurring value. Variance and standard deviation. These are measures of spread that indicate how much the data varies from the mean. Variance is a measure of the average of the squared differences from the mean, and standard deviation is the square root of the variance. Percentiles. Percentiles divide the data into 100 equal parts, and indicate the value below which a certain percentage of the data falls. For example, the 25th percentile, also known as the first quartile, indicates the value below which 25% of the data falls. Correlation. Correlation is a statistical measure of the relationship between two variables. It ranges from -1 to 1, where -1 indicates a perfect negative correlation, 0 indicates no correlation, and 1 indicates a perfect positive correlation. Probability. Probability is a measure of how likely an event is to occur. It ranges from 0 to 1, where 0 indicates that an event is impossible and 1 indicates that an event is certain. Hypothesis testing. Hypothesis testing is a statistical method for testing whether a claim about a population is true or false. It involves formulating a null hypothesis and an alternative hypothesis, and then using statistical techniques to determine whether the data supports the null hypothesis or the alternative hypothesis. It's important to note that understanding statistics is not only about being able to calculate and apply different formulas, but also about understanding the underlying concepts and knowing when and how to use them in practice. Additionally, it's important to understand the assumptions and limitations of each statistical method, and how they can be affected by the characteristics of the data. Exploratory data analysis, EDA, is a crucial step in data analysis that helps to identify patterns, outliers, and other features of the data. It is an iterative process that involves summarizing the main characteristics of the data, identifying outliers and missing values, detecting patterns and relationships in the data, as well as developing and testing hypotheses about the data. EDA is typically done before formal hypothesis testing or modeling, and it allows the analyst to understand the data better, identify any potential issues, and develop a deeper understanding of the problem before building models. One of the main goals of EDA is to understand the underlying structure of the data and to identify any patterns, trends, or outliers that may not be immediately obvious from looking at raw data. This can be done using various graphical and numerical methods such as histograms, box plots, and scatter plots to visualize the distribution of the data, correlation and covariance matrix to identify the relationships between different variables, principal component analysis, PCA, to identify patterns in the data, and clustering to identify groups of similar observations. EDA is also important because it helps to identify any issues or problems with the data, such as outliers, missing values, or errors, that need to be addressed before further analysis can be performed. Additionally, it helps to reveal any potential biases in the data, which can affect the results of the analysis. Overall, EDA is a crucial step in data analysis that helps to identify patterns, trends, and outliers in the data, and it helps to understand the underlying structure of the data. It also helps to identify any issues or problems with the data that need to be addressed before further analysis can be performed. It's an important step in the data science process as it helps to uncover insights and patterns that might otherwise go unnoticed, and it's a good way to develop a deeper understanding of the problem and data before building models. Hypothesis testing is a statistical method used to test claims about a population by using sample data. The basic idea behind hypothesis testing is to compare two hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis, H0, is a statement of no effect or no difference, typically the status quo. It represents the assumption that there is no relationship between the variables being studied. The alternative hypothesis, HA, is the statement being tested, the opposite of the null hypothesis. It represents the claim or assumption that there is a relationship between the variables being studied. The process of hypothesis testing typically involves the following steps. State the null and alternative hypotheses, select a sample from the population and collect data, choose a significance level, usually denoted as alpha, which is the probability of rejecting the null hypothesis when it is true. Commonly used values are 0.01, 0.05, and 0.1. Calculate a test statistic, such as t-value, z-value, or p-value, based on the sample data. Compare the test statistic to the critical value from a probability distribution, such as t-distribution, normal distribution, corresponding to the significance level. Make a decision about the null hypothesis based on the comparison. Report the results in terms of p-values and confidence intervals. In data science, hypothesis testing is used to test claims about a population by using sample data. It can be used to test a wide range of hypotheses, such as testing the effectiveness of a new drug or treatment, determining whether a new marketing campaign is more effective than an existing one, checking if there is a difference in the mean of two groups, examining if a certain variable is related to the outcome of a model. For example, in a drug trial, the null hypothesis, H0, might be that the new drug has no effect on a particular disease, while the alternative hypothesis, HA, is that the new drug does have an effect. The data scientist would collect data on a sample of patients and use hypothesis testing to determine whether the data supports the null hypothesis or the alternative hypothesis. Hypothesis testing is also used in feature selection and model selection, where the data scientist might want to test the impact of different features or models on the outcome variable. It's important to note that hypothesis testing is a probabilistic approach and it can never prove that a hypothesis is true. It only provides evidence against the null hypothesis. It also requires assumptions about the population and sample, such as normality of the data or independence of observations. In summary, hypothesis testing is a statistical method used in data science to test claims about a population by using sample data. It helps data scientists to make inferences about population parameters based on sample statistics and make decisions about the null hypothesis. It's a widely used approach to make decisions and predictions based on the data, and it's a fundamental tool in data science to help identify relationships, patterns, and insights in the data. Correlation and regression analysis are statistical methods used to understand the relationships between different variables in the data. Correlation measures the strength and direction of the linear relationship between two variables. A correlation coefficient is a value between -1 and 1 that indicates the strength of the relationship. A correlation coefficient of 1 indicates a perfect positive correlation, meaning that as one variable increases, the other variable also increases. A correlation coefficient of -1 indicates a perfect negative correlation, meaning that as one variable increases, the other variable decreases. A correlation coefficient of 0 indicates no correlation. Regression analysis is a statistical method for modeling the relationship between a dependent variable, also known as the response or outcome variable, and one or more independent variables, also known as predictor or explanatory variables. The goal of regression analysis is to find the best fitting line, or equation, that describes the relationship between the variables. This line can be used to make predictions about the value of the dependent variable based on the values of the independent variables. There are different types of regression analysis, such as simple linear regression, used when there is a single independent variable; multiple linear regression, used when there are multiple independent variables; nonlinear regression, used when the relationship between the variables is nonlinear; logistic regression, used when the dependent variable is binary, i.e., it can take only two values. Correlation and regression analysis are widely used in data science to understand the relationships between different variables in the data. Correlation analysis is used to identify the strength and direction of the relationship between two variables. It can be used to identify which variables are related to each other and how they are related. This information can be used to make predictions about one variable based on the values of another variable. Correlation analysis can also be used in feature selection, where the data scientist can select the variables that are most strongly correlated with the outcome variable. Regression analysis is used to model the relationship between a dependent variable and one or more independent variables. It can be used to make predictions about the value of the dependent variable based on the values of the independent variables. It can also be used to understand the impact of different variables on the outcome variable, and identify which variables are most important for making predictions. In data science, correlation and regression analysis are used in many different applications, such as predictive modeling, building models that can predict future outcomes based on historical data; exploratory data analysis, identifying patterns and relationships in the data; inference, making inferences about population parameters based on sample statistics; quality control, identifying variables that are related to the quality of a product; marketing, identifying which variables are related to customer behavior; healthcare, identifying which variables are related to patient outcomes.